Hi, in this video, we're going to go over the second part of lesson 8.3, which is on solving right triangles. The essential questions for this section are how do you use trigonometry to find the missing angle measures in a right triangle? We covered that in the day 1 lesson video. And then here for day 2, we want to look at how we can use trigonometry and inverse trigonometry to find all the missing parts of a right triangle. For our first example, we're going to look at how we can solve a right triangle when given two sides. Solving a right triangle means finding all of its missing parts. So right now, I have two sides and a 90-degree angle. So we have two things that we need to find. We need to find the last missing side here, side DE, and we need to find the measures of the missing angles. So for side DE right here, I'm just going to call that side X just to make it simpler for my calculations. So we'll call that X. And if you have two sides, you can find the third side using the Pythagorean theorem, which is the a squared plus b squared equals c squared. Remember that c is always the hypotenuse, which is across from the 90-degree angle. So here the c is x, and then a and b are the other two sides. So subbing in our values, a squared is 20 squared, plus b squared is 21 squared, equals c squared, that's my x squared. Now we'll go ahead and calculate 20 squared, that's 400, and then 21 squared is 441, that's equal to x squared. Combine our like terms here. 400 plus 441 is 841. And now to get x, we need to undo the squared. Remember that you can do that by taking a square root of each side. And if you type the square root of 841 into your calculator, you'll get 29. So the missing side there, side DE, is 29. So now we just need to find the missing angles. And when it comes to which angle to find for like the first missing angle, it doesn't matter which one you do. So you can just pick one. So I'm going to let my first missing angle be angle D. And from angle D, we can label our sides. Remember that we have the hypotenuse, which is always across from the 90. It's the C from before. And then the opposite angle D is going to be the 21, and adjacent is the 20. So if I look carefully here, to find angle D, we have the hypotenuse, and we have the opposite. So if you go back to your SOHCAHTOA acronym, the one that uses opposite and hypotenuse is the SO of SOHCAHTOA. So we want to use the sine function. So sine of angle D is equal to opposite, so 21 over 29. And then to get the measure of angle D, we just need to do the inverse sine of 21 divided by 29. So here I have my graphic calculator. I used the link from Schoology under the resources, and I chose the TI-84 graphing calculator. And before I do my calculation, I need to make sure that I'm in degree mode. Since I just opened the link, it probably isn't going to be in degree mode. Notice that on that fourth line down, it is in radian mode. We need to switch over to degree. And now I'll leave the menu with second quit. And then we'll do the inverse sine, which is second sine inverse, and then it's 21 divided by 29. And if we hit enter here, we get the 46.397, and we're going to be rounding to the nearest tenth, which is 1 decimal position. The 9 in the second decimal position makes it round up. So it'll become 46.4 degrees. So that is the measure of angle D equals 46.4 degrees. Now that we have the first missing angle, we can find the last angle just using the triangle angle sum theorem. Remember that in a triangle, the three interior angles always add to 180 degrees. We just calculated that the measure of angle D was 46.4 degrees. And then this angle right here, of course, is 90 degrees. So we have 2 out of the 3 angles, and we can just subtract that from 180. So 180 is the total, so I'm going to do 180 minus 90 minus 46.4. And when we do that, we end up with 43.6. So that makes the measure of angle E 43.6 degrees. Another way that we could find that would be to remember that in a right triangle, the acute angles add to 90 degrees. Because there's always going to be one 90-degree angle in a right triangle. So if I would just take 90 and subtract the angle that I just found for angle D, which was the 46.4, that would also give me 43.6 degrees. Let's try another example, but this time we are given one angle and one side. So this process is going to be a little bit different. The easiest thing to find right away is the last missing angle. We already have a 90-degree angle and a 25-degree angle, so we're really just missing the measure of angle G. You can either do 180 minus 90 minus 25, or we can use the fact that the two acute angles always add to 90. So if I just take 90 minus 25, that is equal to 65. So that means that the measure of angle G is 65 degrees. So now we have all the angles. Next, we need to go ahead and calculate the sides. It doesn't matter which side you calculate first. So I'm just going to pick a side to calculate first. Let's say we want to start with side GJ. So I'll call that just side X. And setting up a trig ratio with the angle that was given. I would use that instead of the 65, just in case I messed something up. I know 25 is correct because it gave me that at the beginning of the problem. So labeling our sides in relation to the 25-degree angle, we have the hypotenuse is 13, opposite the 25 is the X, and this side right here is the missing side, blank one is adjacent. So beginning with finding the X, we have an opposite and we have a hypotenuse. So if you look at your SOHCAHTOA, the one that uses opposite and hypotenuse is sine. So we'll have the sine of the angle, 25 degrees, is equal to opposite X divided by hypotenuse, 13. So I'm using the SO of my SOHCAHTOA. Now that we've done this, we're going to go ahead and solve with cross products. So I'm making sine of 25 into a fraction by placing it over 1. And now our cross products are equal. So 13 multiplied with the sine of 25 degrees is equal to 1 times x, which is just x. And since x is already just by itself, all you need to do is grab your calculator, make sure you're in degree mode, and if you type in 13 times sine 25, the calculator gives you 5.49. Again, we'll be rounding to the nearest tenth, which is 1 decimal position. So the 9 in the second decimal position means we round up. So that would be 5.5. I do want to go back, though, to naming the side with the letters. So side GJ or JG is equal to 5.5. And now we'll finish it up by finding the last missing side, side HG. I'm going to name that Y just to make it easier here. And always go back to the full number. So I don't want to use 5.5 in my calculation because this 5.5 right here is a rounded value. So when we're doing the last one, we want to go back to, well, I know that the hypotenuse is exactly 13. And if I have the adjacent Y and the hypotenuse of 13, we can use the cosine ratio where we have cosine of 25 degrees equals adjacent Y divided by hypotenuse 13. And now I'll just set up my cross product here. So 13 times the cosine of 25 degrees is equal to 1 times Y, which is just Y. And then grab your calculator and type 13 times cosine 25. And you'll get 11.78. Let's again round that to 1 decimal place, so 11.8. And then I want to name it with the letters. So this is side HG or HJ. And that would round again to 11.8. So now we have all of the missing parts in our right triangle. The measure of angle G was 65 degrees using the angle sum theorem. We used trig functions to find the first missing side, side JG, 5.5, and then we just used trig functions a second time to find side HJ of 11.8. Here's a try now problem that is very similar to the one that we just looked at. I'll go through this one kind of quick. If you'd like to try it on your own, feel free to pause the video and then hit play in a minute and I'll have the answers come up as I talk through them. Similar to the last problem, we have one side and one angle. So the first thing I'm going to do is find the last missing angle, which is angle Y. So the measure of angle Y is going to just be 90 subtract 52. In a right triangle, the two acute angles always add to 90 degrees. And when we subtract 52 from 90, we get 38. So the measure of angle Y is 38 degrees. Now we need to find the two missing sides. So I'm going to start off by just picking side YZ. So I'll call that side X. And let's go ahead and label in relationship to the 52 angle that was given. That's the opposite. Hypotenuse is unknown and adjacent is the 8.5. We have adjacent and opposite. So if we go to our SOHCAHTOA, the one that uses opposite and adjacent is tangent. So I have the tangent of 52 degrees is equal to O, which is X, divided by the adjacent of 8.5. Now we can solve for that side using our cross products. 8.5 times the tangent of 52 is going to equal X. Grab your calculator and type that in. And when you do so, you are going to get 10.87. When it comes to rounding, 7 makes us round up. So we'll have that first missing side, and I want to go back to letters. So side YZ is equal to 10.9. To finish it up here, we need to find the last missing side. I will call the last missing side Y. And so that's my hypotenuse, and then I want to use the side that was given. I don't want to use 10.9 because that's a rounded number. We always want to use exact numbers when we set up our trig functions. Using A and H, you can see that's the CA of SOHCAHTOA. So we'll have the cosine of 52 degrees equals adjacent 8.5 divided by the hypotenuse, which is the y. We can then solve it with cross products. Y times the cosine of 52 is equal to 1 times 8.5, which is 8.5. We're not quite done here yet, though. We need to get the y by itself. So we need to divide out that multiply by cosine 52. That'll cancel it out. And to get our final answer, we just need to grab our calculator, make sure we're in degree mode, and do 8.5 divided by the cosine of 52. And when you do that, the calculator will give you 13.80. The 0 rounds down, so my last missing side here, side y, which is really in my picture, I want to go back to the letters. So xy equals 13.8. And now we have our triangle solved. We found all the missing parts. Before we end this lesson, here's a few things that I added to the things to remember tips section of my notes. Feel free to pause the video and write this down. First, if you know two sides in a right triangle, that was the first example that we looked at today. If you know two sides, you can use a squared plus b squared equals c squared to find the missing side, and then use inverse trig to find an acute angle, and then do the triangle sum theorem to find the last missing angle. If you know one side and one angle, that was the last two problems that we just went through, you can find the missing angle using the triangle sum theorem, and then use trig to find the first missing side, and then use trig again to find the last missing side. This concludes lesson 8.3, day 2. Thanks for watching. Bye.